Now it's 10 p.m. in Malaysia. So good morning, good afternoon, and good evening to everyone. My name is Wong Chiuan from Malaysia. Then I study in Universiti Teknologi Malaysia. And then my supervisor is Dr. Muhammad Rizwan. He's also inside the meeting. Then the topic I'm going to present today is smart switch based on embedded machine learning. So here's some introduction. So the problem background, so we can see here is a conventional switch. A conventional switch is a very normal electrical appliances in every house. However, there's some problem because it's a conventional switch. The first thing is we need to get closer enough to the switch to use our finger to switch on or switch off the switch to control other output. It seems like easy for us. Then, however, for people who have physical disability, actually it's quite hard for them to reach the switch because they need to move to the switch, then reach to the switch and switch on or switch off the electrical appliances. And beside that, because we need to use our finger to touch the switch there, so if we're using a wet hand to touch the switch, we also have a risk of getting electric shock. So we can see here, there's so many disadvantages for this conventional switch. So how we solve this is we provide an alternative input besides manually. So it also can be called smart switch using an alternative input such as a voice control or motion control. So for today's my sharing, I will be using voice control smart switch. So smart switch, there's many kinds of smart switch, and here we talk about the IoT-based smart switch. So IoT is an Internet of Things smart switch. So using internet to control the smart switch. So because it using internet connection, so when the internet connection is slow, there will be a high latency problem between the cloud server and the microcontroller. The data transmission will be affected by the internet connection. Besides because it is high dependent on internet connection, so when that places is without internet connection, then the switch might cannot work because there's no internet connection for the data transmission. And then the last one is the data privacy problem, because our data is stored inside the cloud server. So when there's maybe some hacker problem, then our data will be leaked from the cloud server. So here is we can see some disadvantages because of the internet. So I sharing this that smart switch they're using embedded machine learning. So embedded machine learning or can be called as TinyML. So the machine learning model is embedded inside the microcontroller. So we're actually not dependent on internet connection. So however, there's solved the problem of internet because it's not high dependent on the internet. However, there's also some problems such as the accuracy problem, or the data sample is too personalized. So the data sample need to be collected correctly and accurately, and not too much noise, so the accuracy will be higher. So here's the scope of this project. So I'm using Raspberry Pi Pico as the microcontroller, and then using a electric microphone amplifier as the sensor, receiving the voice signal, and then using edge impulse to make the machine learning model, and then using Arduino IDE to program the microcontroller. So here's some flow chart. First, the sensor, the amplifier will receive the voice command, then the microcontroller will receive the voice command, then the machine learning model will decide the labels such as light on, light off, noise, and then depend on the light on, light off, and the current light status is on or off, then by different command, then decide the relay output is giving low or high to control the output. So this is the microcontroller, Raspberry Pi Pico, And then there's some component used, such as the 200 volt to 5 volt converter and this microphone amplifier. And then using a 3 volt relay because Raspberry Pi because it's a 3 volt device. And then optocoupler for sensing the current status of the output. Is it high? Is it on or off? So, then in this switch, I'm using two-way switch schematic so that the switch can be controlled manually or voice control. So for the software, you're using H Impulse for the machine learning model and the Arduino IDE for the programming. So the first step, I'm using the H inside the H Impulse. I collect data for training. I collect 5 kind of data, such as Pico. I keep speaking Pico to my Pico. Then also I also collected light on and light off. Also unknown voice, random voice, and noise. Then generate feature using H Impulse. Then I train the model also using H Impulse, receive the training output, then create the library. There's some library, then I using Arduino library because I using Arduino IDE. And then include the library, then write the code using Arduino IDE. So here's some result. So here's is some small prototype of the smart switch. And then here's an expected result. So I'm using 3 kind of method to test my prototype. So the first one is using manually, only the manual switch, and then using voice control. Or mixed method, I will manually on first, then using voice to turn off, and then using voice to turn on, and then manually turn off. So here's some video. So this is the manually on, and then the manually off. And then using voice to turn on and turn off.
Light on.
And then the turn off.
Light off.
And here's the first one is manually turn on first, then using voice to turn off.
Off. Light off.
And then using voice to turn on, then using the manual switch to switch off.
Light on.
Okay, so as the conclusion, so for this project I built a small prototype, and then the machine learning model library is developed using the H Impulse. Then the result also produced the expected result. Yeah. So here's some reference for the presentation. So thank you. That's all for me. So do you have any question?
Yeah, cool. So awesome work. Yeah, cool to see applications of keyword spotting here. Did you notice any particular high false positives that you would hit for some keywords? What did you do to correct that or account for any false positives you might be seeing?
Sorry, can you repeat the question again?
Yeah. How many false positives did you see when you actually deployed it? Was it a lot? Because things rhyme with lights, yes. Things rhyme with on. And did you do anything to to help correct that or make it a little more robust?
Actually, it's quite hard to using the light on. Actually, the accuracy of my actual product is quite low. The video inside the result actually I shoot many times. So I use different methods, such as I use simpler word and not using light anymore, because light on and light off both keyword have the same word light. So I just shorten the keyword to on and off, yeah, or on and turn off to differentiate the keyword. Yeah.
Yeah, that's smart. Doing multiple syllables does seem to help, which is why we have like Alexa or some of these others. It's like not a super common word. Yeah, well done.
Yeah. Nicely explained project. Oh, it was really good.
from a time base, we should switch over to Laila's group. Any quick questions for Wong before we switch over?
Can I ask you a quick question, if you don't mind? Question that I have is like, so what were some things that you found hard to do that you wish were easier or simpler?
I think it's how to use the library, because Raspberry, because at that time Raspberry Pi Pico is not supported by H-Impulse that time, so it's quite a hard time to let the Arduino library to use inside a Raspberry Pi Pico. Yeah.
Okay, thank you. So Laila and Karina,
yes,
one of you going to take over the screen?
yes, I will share the screen. Let me know if you can see it. It's okay?
Except it's me.
Okay, you can see the video here? Okay,
Yes.
I will play it. Let me know if you can see it, okay.
Hola, buenos días, buenas tardes. Nosotros somos un grupo interdisciplinario que trabaja en el Centro Atómico Bariloche, en Río Negro, Argentina, y les vamos a contar nuestros avances sobre el estudio de movimiento de animales. Nuestro grupo interdisciplinario está formado por físicos, biólogos e ingenieros, y justamente aprovechando esta diversidad de conocimiento en distintas áreas, nuestro trabajo va desde el trabajo de campo con el monitoreo de animales, incluyendo el diseño y desarrollo del equipamiento, así como también análisis de datos y desarrollo de modelos teóricos de movimiento animal. En particular, en esta presentación les vamos a contar sobre nuestros avances acerca del estudio de la tortuga terrestre Quelonoidis chilensis. Es nativa de nuestro país y a la izquierda les mostramos una distribución estimada de esta especie. Nos parece importante contarles que es una especie en estado vulnerable y se encuentra amenazada por distintos factores, por ejemplo, la fragmentación de su hábitat, el mascotismo y la introducción del ganado. Bien, entonces, como grupo interdisciplinario de trabajo, nuestro objetivo principal es responder preguntas básicas acerca de la biología de diferentes especies animales, en particular en este caso de la tortuga Quelonoidis chilensis. Bueno, ¿de qué manera hacemos eso? Primeramente realizamos un monitoreo de diferentes individuos de la especie en cuestión y caracterizamos su comportamiento. Con monitoreo no me refiero solamente a la observación directa de individuos, sino al uso de equipamiento específico para el rastreo. Por ejemplo, equipamiento con GPS y sensores inerciales, acelerómetros, giróscopos, entre otros. Además, la información obtenida con estos sensores podemos complementarla con modelos teóricos de movimiento animal. En esta presentación, entonces, les vamos a contar sobre un diseño y desarrollo de equipamiento que realizamos nosotros y cómo lo estamos complementando con el uso de los kits de TinyML. El uso de estos kits nos está ayudando a optimizar el monitoreo del cual les hablaba. ¿De qué manera? Usando los kits junto con técnicas de Machine Learning, podemos detectar automáticamente las actividades de los animales. Si está comiendo, caminando, copulando o realizando alguna actividad que pudiera resultar de interés biológico. Esta detección automática permite, a su vez, optimizar la autonomía del equipamiento. Por ejemplo, si con el uso de los acelerómetros se detectara que el individuo no se está desplazando, tal vez se está moviendo pero sin desplazarse en el espacio, por ejemplo, si estuviera en un mismo sitio comiendo, podría disminuirse la tasa de muestreo del GPS, mejorando así la autonomía del equipamiento. A continuación, entonces, vamos a comenzar mostrándoles el equipamiento con el que venimos trabajando antes de recibir los kits y luego les vamos a contar de qué manera los estamos complementando.
Hasta el momento hemos utilizado un dispositivo creado por nuestro grupo que cuenta con GPS y sensores inerciales varios, tales como acelerómetro y giróscopo, para realizar el monitoreo de las tortugas. A su vez, el grupo se encuentra trabajando en el desarrollo de una nueva versión de este dispositivo que contará con un firmware y hardware más flexible para poder utilizar el mismo en otras especies de animales y mejorar el consumo de energía y el tamaño, lo cual implica un mayor grado de autonomía. En forma adicional, esta nueva versión contará con la posibilidad de realizar telemetría a la frecuencia de 150 MHz, que es la frecuencia para la cual el grupo ya cuenta con un equipamiento específico. Y el mismo será compatible con Tiny Machine Learning. Hasta el momento, contamos con datos recolectados de 8 individuos en su hábitat natural, los cuales fueron obtenidos durante la primavera del 2020 y el verano del 2021 tras varios días de monitoreo. Los mismos están compuestos por los datos del GPS y del acelerómetro. Durante el monitoreo se realizaron observaciones visuales de las actividades de las tortugas en diferentes momentos del día. Es a partir de estas observaciones que se logró asociar los comportamientos vistos con los valores de los sensores, pudiendo hacer una etiqueta de los datos. A partir de las mismas se realizó el entrenamiento de un algoritmo de Machine Learning para poder detectar los diferentes tipos de comportamiento del animal, buscando hacer una clasificación de los mismos en tiempo real. La imagen que pueden ver es la de una tortuga que está colocando sus huevos, y a la derecha se observan los valores de, en este caso, el acelerómetro para el eje X, Y, Z, donde claramente se puede ver un patrón de la señal.
En una primera instancia, nuestro objetivo fue diferenciar en la señal del acelerómetro el comportamiento, movimiento y quietud de la tortuga. Para esto se segmentó la señal de acelerómetro en ventanas que fueron introducidas en la plataforma Edge Impulse. Se realizó un preprocesamiento de la señal siguiendo 3 métodos diferentes. En primer lugar, se introdujo la señal cruda, luego también se utilizó el método de características espectrales y finalmente el método de espectrograma, todo utilizando la plataforma Edge Impulse. Como resultado de la aplicación de los 3 métodos, como puede verse aquí en la tabla, obtuvimos que el método de espectrograma es el que resulta más satisfactorio y con él es posible diferenciar entre el comportamiento de movimiento y quietud de la tortuga con una buena precisión. De esta forma, utilizando el mejor de los métodos, que resultó ser el de espectrograma, entrenamos una red neuronal en la plataforma Edge Impulse con el objetivo de exportar luego el programa entrenado y poder diferenciar entre movimiento y quietud en tiempo real. Una vez entrenada la red neuronal, el modelo se exporta utilizando Arduino al dispositivo de TinyML, o en este caso, como se ve en la figura de la derecha, se exportó a la WIO, y como puede verse, la WIO diferencia en la pantalla lo que es actividad de movimiento cuando pasa al color verde. Además, implementamos la posibilidad de que se pueda detectar en el celular, en tiempo real, este cambio de comportamiento que indica la red neuronal entrenada en el dispositivo de Tiny Machine Learning.
Bueno, como comentábamos al principio, y justamente con la idea de complementar nuestro equipamiento con los kits de TinyML, compramos GPS, memoria y baterías para justamente adaptarlas a estos kits y convertirlos en un equipo para monitoreo de animales. A la derecha mostramos un prototipo que armamos el cual se encuentra ya funcionando y está programado con Arduino. Esto nos permite guardar la latitud, la longitud, la fecha, la hora, y además podemos ir guardando estos datos y los de diferentes sensores en una memoria SD, con una tasa que es configurable. Además de esto, podemos configurar de manera remota usando Bluetooth la activación o desactivación, por ejemplo, de la escritura de estos datos en la memoria SD, o activar o desactivar el envío de datos por Bluetooth. Bueno, como información adicional, posteriormente a los workshops que hemos tenido organizados por USTHB y por recomendación de colegas de esta red, participamos hace aproximadamente 2 meses de un concurso en Seed Studio y ganamos el premio a un proyecto innovador y creativo, accediendo así a equipamiento de Seed, el cual vamos a utilizar justamente para complementar este trabajo de monitoreo de animales. Les contamos entonces algunas conclusiones e ideas futuras. Con los kits podemos clasificar movimiento y quietud en tortugas y otras especies, pero actualmente estamos clasificando además nuevos comportamientos: cópula, pelea entre machos, excavación de hembras para depositar sus huevos en la tierra, entre otros. Queremos notificar a los usuarios la actividad de los animales clasificada en el momento. Además, utilizar esta clasificación precisamente para optimizar la autonomía de los dispositivos. Como les comentamos recién, incorporar GPS, baterías y memorias a los kits y convertirlos así en dispositivos de monitoreo animal. Además, aprovechar otros sensores de los kits como micrófonos para clasificar comportamientos específicos. Bueno, utilizar todo esto en otras especies animales y complementar todo con nuestro diseño y desarrollo, el cual es compatible con TinyML. Bueno, les agradecemos mucho por la atención y quedamos disponibles para cualquier consulta. Gracias.
Okay.
We have some time for questions for this project. Really interesting, the merging of the motion sensor with potentially sounds and real machine learning stuff there. That's great. Anyone, any students with any questions?
I think there might have been a question in the chat from someone earlier, which was just asking what level everyone on the project was, because I think it was really impressive, and some people were like, "Oh my God, how did you do all of this? How long did this take? Did you know everything in the beginning?" So I'm wondering if you could just speak to a little bit of that for the group.
Well, I can tell if you want a little bit about our group. Can you hear me okay? Yeah? So, great. So we actually, Andres, that is an engineer that is doing his master thesis here in Bariloche. He is the one that developed the new device that we showed in the presentation. With Laila is now Laila is postdoc, but was postdoc, but recently entered into the researcher career. So, congratulations, Laila. And so, in our group, that we are an interdisciplinary group of physicists, and we work together with engineers. So, Laila is starting with the research career, and I am an independent researcher from CONICET, and we are advisors of Andres, that is here present, together with another engineer that is in fact in Italy now, I think, or during these days. So So that's it. And with Laila, we were struggling, like doing this, how do you say, soldando, like the work of putting together the batteries and the GPS and everything. And so we were doing the experimental work there, and we work really together. So we are about 4 or 5, and also David, that unfortunately he couldn't connect it, but because he's finishing his master, and he's with all the stuff of the exam, so he couldn't connect. And also there is another physicist that made the actually this is nice because he made the connection between a Bluetooth connection between the cell phone and the wheel, and actually he wrote a tutorial that maybe we can share with you after this. Yeah, he is on class, so he couldn't connect also, but he made a tutorial with all the steps, so to do everything. So we are about 5 or 6 people working together.
Wow. Yeah, I bet Sean from Edge Impulse is fairly impressed with the using motion to understand more of what's going on. That's really, really impressive.
Yeah, I really enjoyed that. And then combining it with sensor fusion to really track the animals seems like a really smart way to do things. Quite impressive, great project. How did you like doing the, did you find that the 1D convolution worked better than like a 2D? Like, why did you end up using 1D convolution?
Well, actually, this is a nice question because David, that cannot be here, unfortunately, but he is the one that is like trying different methods to differentiate the behaviors. And so he tried with the convolution, and he can classify like mostly the X when the turtle put the eggs on the ground. So this is a very characteristic movement, and he can differentiate it very easily with the convolution. But then we are struggling with the differentiation between, for example, eat and walk. So those are very similar signals in a sense that we cannot easily separate or classify with the convolution. So we are now working hard on this. But the laying eggs behavior is very, very characteristic, and we can do it with and this is important because we can protect the nests of the turtles. So we are now the next step will be to put this that will be probably in February or March, next February, to put this device on the turtle, on the tortoise, to see if we can classify something.
Yeah, great talk, and it's a really fantastic project. Thank you for sharing.
Thank you. Thank you very much.
From a time base, I have noticed one of our other presenters in the chat. I still haven't seen Jacqueline and Dadan. If they can say hi in the chat, that would be good. They're our last presenters. Coming up next, Suleiman and Yasmine. Are you guys ready to take over the screen? Yasmine?
Yes.
Okay. Excellent.
Before I get started, I would like to present my team to you. We are Koulal Yidhir Aghiles, Labchri Amayas, Bourzam Saad, Bourbia Amine, and me, Baroud Yasmine. We are a group of enthusiastic visual computing students from Universiti Science and Technology University from Algeria. and we are honored to represent you our humble work which onboard the subject of human-computer interaction, especially in hand gesture recognition using Tiny machine learning keys, which received from 1 month ago. In this presentation, I'm gonna talk about the problem, use case, proposed solution, the set of gestures to recognize, data collection, Arduino communication, gestures classification models, and I conclude with a conclusion. So, with the development of daily using computing, current approach of user interaction with different electronic devices throughout different inputs such as keyboard, mouse, controllers, etc. might seem inflexible and limited for some users. And many nowadays platforms such as interactive environments require more natural and intuitive user interaction such as hand gestures. Therefore, accurate interaction between humans and machine can be achieved using hand gestures. This technology is used in many fields like virtual environment interaction, smart house, and more. To solve this problem, we come up with the idea of the interaction with simulating game using two Arduino Nano 33 BLE sense. Inside of the computer input to achieve a more accurate human-computer interaction by training them on different hand gesture recognition. The reason why we are using two Arduino instead of just one is because there are some hand moves that can't be made by one. Now I'm gonna show you the 7 gestures that we defined. We have jumping, which translated by raising the arms. Moving down, it translated by lowering them. Moving right, it translated by moving the arms right. Moving left, it translated by moving arms left. We have also protect and shoot, which translated by moving the arms in horizontal opposite way. Speed is translated by moving arms in vertical opposite way. For data collection, I'm letting my friend Labchri Amayas to present it to you.
Good afternoon, everyone. Can you hear me? So now I will present to you the data collection phase. So the data collection is performed by taking for each hand gesture a number of repetition, where each repetition return a number of samples, obviously 190. Each sample is represented by 6 values. The first 3 values represent the acceleration coordinates, Ix, Iy, Iz, and the last 3 values represent gyroscope coordinates, Gx, Gy, Gz. And we repeat this process for each hand gesture, as you can see. So here is an example how we collect the data. We take the Arduino in one hand, and we can raise up our hand or to move to left or move to right. And we collect the data and we save it in CSV files where we will use it in our classification model training. Now I will show you a video that shows this process. I raised my arm up and we are starting collecting the data. We repeat this process 4 times. Now, I will present you the communication between the Arduinos. So, we set the communication between Arduinos using the UART communication protocol, well known as Universal Asynchronous Receiver Transmitter. It allows us an asynchronous serial communication in which the data format are sent between the transmitter Arduino to a receiver Arduino. This to connect the distance between them. Now I will show you our model architecture. We built our model based on work of Mr. Sanjeev and Don Clement collaboratory, and we make some changes in the model. So we take 714 inputs where they go through the hidden layer of 50 nodes, and the result will be, we will have 4 outputs. The first represent the move up, the second down, right and left. Now we will discuss the graph. So we can see going without epochs, we are having the training loss and validation with decrease, starting from epoch 20 epochs. Oh, sorry. Now we discuss technical and validation accuracy. So we got an accuracy of 91%. And okay, we have some mistakes, you can see here. Now we will present our system. So someone can use, will use 2 Arduinos with 2 hands and make a movement simultaneously with them. Each Arduino will send his data to the image classifier to make a prediction. Who set the data to the model make a prediction, and they will send it again to the Arduino, left and right. And we set the predicted movement in the right Arduino, which represents the transmitter Arduino to the receiver Arduino. The receiver compare between the 2 predicted class. For example, if the Arduino right do up, so to return 0, and the Arduino left raise his arms up to be a 0, so we will get final gesture prediction that is made by the 3rd Arduino to represent jump. Now I will show you a demonstrative video of test. So here, so we have 2 consoles. The COM20 represents the transmitter Arduino, and the COM30 represents the receiver Arduino. So here we moved on our 2 arms simultaneously. So the result was index 1, so down in the transmitter Arduino, and for the receiver Arduino, we got also just predicted down. So when we combine the 2, we get down. We can see that our model gives good predictions, and if we do a false movement, it will show us an error. Okay.
As a conclusion, it has been a pleasure for us working on this project, especially since it's our first time using this technology, and we look forward to have the chance to optimize our solution and work on future projects using the 33BLE Sense Arduino and other edge impulse technology as much as we would. I would like to express our appreciation to our teacher, Lara Bisliman, for his unlimited advices and supervision. We express our gratefulness to Edge Impulse and ECTP Institute, who supplied us with this technology. We also want to express our thanks to Don Colimon, Sandeep Mistry, and Dominic Pajak, who created the Arduino classification code example. Thank you.
Thank you so much. That was a great presentation. The combining of the 2 Arduino ML kits is brilliant idea. Coordinating that with that Gym Pulse is really impressive. Any questions out there?
I have a quick question. I think that's super cool how you're doing a model in each and then using that for gesture recognition. And then, so let me make sure I have this straight. So the right one would send to the left one, and then the left one would look, and then the left one would look at the model, the inference results of both, and determine which gesture you were doing, right? So you're like combining two inference results. Is that right?
Yes, that is it.
Yes.
Okay, yeah, that's really slick. I like that. You saw it for, like, I saw your like protect speed coming up. So the intention is for like a video game controller or some type of like assistive technology as a different type of input.
Yes, it's like.
Excellent. Great presentation. Thank you.
Thank you.
Thank you.
Any other questions?
I have one. For example, you guys use it a fusion between accelerometer and gyroscope. Did you also try only with accelerometer to see or if it's work well, and if using both, how you think that became better? You know.
Can you repeat? It's lagging connection.
Yeah.
Please.
Okay. Use a sensor fusion connecting accelerometer and gyroscope. Why that? I mean, you also try only with accelerometer and see that with both became better.
So we want to also to use Bluetooth connection between them. If you are talking about sending the data between two Arduinos, making communication.
No. I'm talking about the sensors. You have two sensors as input, correct? Accelerometer and gyroscope. I mean, why use both? I mean, only accelerometer was not enough. You studied that?
Yes. Okay. I will give you an answer for just the speed. How can you use it just using one arms? With smart projection, it's like when you use two arms like that. It's like when you run with your feet. You want to represent that.
Okay.
We used Arduino to present more gestures.
So you can represent more gestures using two arms than one. If we use two, we can 4 factorials movement. We can represent can define 4 factorials movement in our system.
Okay. Any other questions coming through? We are running close to our hour. I think our final presenter, Jacqueline and Dadan, I haven't heard from, and I don't think we have enough time for them. I've seen in the chat MD Sharif. So final
yes.
conclusion. Oh, good. Okay, so MD is here. Yasmine's group, any final questions for the presenters?
I would just note to them that Sean's putting some cool stuff in the chat. They should take a look at.
Yeah, I just dropped in the chat. If you're, I think what Marcella was getting at was the idea of like, do you need the gyroscope? And there's some techniques like feature selection. There's some really cool feature selection techniques out there that will help you determine, rather than just retraining models with just the accelerometer, you can actually do these feature selections to see if, yes, we do need the gyroscope, or we need 2 of the channels and 1 channel from the accelerometer. So I recommend looking into that. Feature selection is really cool.
Thanks, Sean. MD Sharif, do you want to take over the screen? And then we're getting pretty close to our hour. Go ahead. If
Jacqueline is here, yeah.
Yeah. Hi, everyone.
It's Jacqueline, no?
Thank you for giving me opportunity. My slide is short, so I guess it will not take much time.
Do you want to share your screen or?
Yes, I'm sharing
there we go.
my screen.
I can see it.
Yes. And Hi, my task is I started with automated American Sign Language using TinyML, and it is a work in progress. So I'll just show what I am just started to start. And my name is MD Sharif Ahmed, and my supervisor is Dr. Prabha Sundara Vadivel, and I'm a master's student of University of Texas at Tyler. In my project, I used Edge Impulse platform and Arduino Nano BLE for implementing these things. Right now, I'll go to display the famous Edge Impulse platform with which I tried to implement it, and I tried to implement these things with the default accelerometer sensor that is inbuilt in the Arduino, and I picked up some data like stationary, bad, nervous. I took only the accelerometer data. Busy. Bad. And with that classifier, I can separate those data. I got some bad data here, incorrect dosor, and those using this platform, those are classified data. And I just used these things like this is for good. So this is for good, and this is for bad. Accuracy is not like 100% correct as it's work in progress. So we try to just show our interest in this platform. Thank you.
Thank you. While we have questions for that, Marcello, is the last presenter here?
Yes. My advice, maybe Jacqueline could present her, and you can make questions at the end. I think it's interesting to see Jacqueline.
Okay, Jacqueline, are you up?
Yeah, sure. Let me just share my screen. So can everybody see my screen?
Yep, we're good.
Yep.
Okay, so hi everyone. My name is Jacqueline Tom. I come from Dedan Kimathi University of Technology, and I am a co-organizer at TinyML Kenya community. Okay. So we worked on a project on using TinyML with audio classification to be able to detect when the bees want to swarm away from the beehives. So the major problem that made us to work on this project is first, a third of all the food supply that we have in the continent depends on bee pollination. And at the same time, we are losing bee colonies at a rate of 30% annually. Here in Kenya, most of the beekeeping done by farmers is traditional, and they face a lot of challenges. I'll mention 3 of them. So one is that during the night, thieves steal the hives, or some may harvest the honey, which will lead into their losses. So we have a case of where up to 40 hives were stolen in a night. So the second problem is human and honey badger conflicts. So these are some fearful animals that jump on these beehives, they destroy them and eat the honey inside, and they result up to 14% of the annual hive destruction. So another problem is pest and disease infestation, because as I mentioned, most of the beekeeping happening here in Kenya is traditional. Therefore, the farmers don't have a clue of all the conditions that is happening inside the beehives. Rather, when they get to their beehives, they get that their bees have either disappeared or some of them have died. But the major problem is most of these bees usually swarm away from their beehives. So this prompted us to build an application that could be able to help these farmers, one, to be able to detect when the bees are able to swarm away by using sound classification, and using other sensors such as DHT, we could be able to also monitor the internal conditions of these beehives. So here was the solution. So using DHT, you could tell whether it's too hot, that could result into poor honey quality. If it's too dumpy, using humidity, that could lead into pest and disease infestation. So using weight, you could be able to tell when honey is ready to be harvested so that it could not be eaten by these bees themselves. And using sound classification and TinyML, we could be able to detect whether the queen is present in the beehives. And if it's not, then the farmers need to be able to put a new queen in the beehives to prevent them from swarming away. So I will move quite fast because of time. So here we have the project architecture. So we trained an audio classification model from a GIMPulse with 3 classes. Queen is present when the queen was absent, and sounds of bees when they were disturbed. Then we deployed this model onto an Arduino Nano 33B license where inference was performed, and then transmitted these inferences to Azure IoT Hub through Sigfox network, because that was the only LPY network, or rather the one that was available in our region. So using the Arduino MKR 1200, which we connected with the Arduino Nano 33B license using I2C, and then integrating Azure IoT, Azure Functions, and Twilio, we could be able to send messages to farmers using SMS. So we chose SMS instead of a mobile app because most of the farmers here are using the analog phones, not the smartphones, but we'll work on a mobile application in a later date. So that is images of us deploying the device. So we use solar, and one of the challenges that we noticed is one, so we were not able to get a battery that could last up to maybe 3 months unless it wasn't available in our country, but maybe available outside. But using solar, though we were able to use solar, it was an invasive powering method in our project. And also using the sounds that we collected from the internet, they were accurate. Yes, we were able to build a model that was 99.2% accurate, but then on going to test it in a real beehive, and then we noticed that there were lots of false positives and false negatives. So therefore, there is a need to collect your own data from the beehives, train a model, and deploy it back to the beehives if you want a better device or a more accurate device. So the next thing maybe we could try, or further steps, is to try sensor fusion. If maybe we could work with an accelerometer, build a model, and to be able to detect when these beehives are being stolen, so through motion. Thank you so much.
Great. Jacqueline, I have a question here. I didn't understand why solar was an invasive powering method. What means that?
Oh, sorry, I've been unmuted. Sorry. Okay. Why solar was an invasive powering method is because bees don't want a lot of interruptions inside the beehives, but the way we connected our solar and all the wirings in order to be able to connect to the battery, which was embedded inside the device, we 3D printed a casing, then put the battery and all the other hardware inside, and using that casing, so there were wires that were surrounding these beehives in order to be able to get inside the device. Because one, this device was placed inside the beehive and the solar was outside. So that's why I mentioned, yeah, it was invasive.
Understand. Thank you. Great project. Yeah, very interesting.
I think I can stop you sharing the screen. Do you want to get out of sharing the screen there?
Oh, I'm actually trying to do that, but you can help me. Oh, sorry.
Yeah. Okay. Let's see. There you go. Timing wise, we're doing very well. We wanted to keep these to an hour. Any quick question for Jacqueline there? The bees assignment?
No, just great project, and thanks. Good talk too. It's interesting to see these kinds of uses of TinyML.
Yeah, really excellent. all the presentations, really, really good. Thank you so much for joining us. Any last words?
Well, I think we should just say that anybody that we that still wanted to present, or anybody else that wants to present again, or new projects or other projects or in progress projects, you know, and get ideas and get support from the group, we're going to keep having these. We'll have some new ones we'll have more of them in the new year. So keep that in mind. Let us know if you'd be interested in presenting. And Jeremy, I think we had scheduled the first one for like towards the end of January to let everyone,
Yes.
you know, have a nice holiday, get back and spend a week or two back home. I think it was the Thursday, the 26th, maybe.
Yes, 26.
Right?
Yes.
Yeah. So I hope to see you all back then. We'll send out more emails. And yeah, I also think I just want to encourage, if anybody has more in progress work they'd like to present and ask the group for thoughts and advice on, or something that wasn't working for some surprising reason. I think that's also very good for everyone to see, so that we don't all make the same mistakes again. I know that I've had plenty of things fail, generally not enough data. But that would be that. And I hope everyone has wonderful holidays.
Yeah.
That's very nice. Happy holiday for everyone.
And we'll touch base again in the new year. Thank you so much.
Great projects.
Bye,
Thanks for
guys.
hosting.
Thank you. Thank you.